Chapter 0, Lesson 2 on real numbers. Okay, so the first thing we're going to talk about is a number line. So we've seen lots of number lines. And just as a reminder, 0 always comes right in the middle of our number line. And everything to the left of the 0 is smaller than 0. And it's always a negative number if it's less than 0. And everything that is to the right of 0 is a bigger number, and it has a positive value. So we have positive and negative numbers, and positive numbers are always going to be getting bigger to the right, and negative numbers smaller to the left. Okay, now let's talk about some different groups of numbers. So when we talk about our natural numbers, there are counting numbers. So when we learned to count as a young kid, we counted 1, 2, 3, 4, 5, and so on. So this group right here is called our natural numbers. Now our whole numbers are very similar to our natural numbers, but we just add in a 0. So now our whole numbers are going to be 0, 1, 2, 3, 4, 5, and so on. And those are our whole numbers. Our integers then take that, the set of our whole numbers, but now we add in the negatives. The only thing we remember with integers is it does not include any decimals or fractions. So our integers, we put dots at the beginning, and then they're -3, -2, -1, 0, 1, 2, 3, and so on. They go on and on in both directions, and those are a group of integers. Now, when we talk about square roots are when we look for one of two equal factors of a number. So when we think of factors, it's two numbers that multiply together to give us something. And if those two numbers are equal, they're the same value. So if I'm going to find the square root of 64, I'm going to say, okay, what number, if I multiply it by itself, gives me 64? So two factors that are equal to each other, and that is 8. Now we also have to remember that if we take -8 times -8, it also gives us 64. We call the 8 here our principal square root because it's the positive value of it. But -8 is also a square root of -64. When we talk about perfect square numbers, we are talking about a number with a rational square root. So basically it means a number that's going to either be an integer or it might have a decimal, but it's going to terminate. It's going to be a short decimal. So numbers that are a perfect square are numbers like 25 because it comes from 5 times 5. Numbers like 121 because it comes from 11 times 11. Numbers like 2.25 because it comes from 1.5 times 1.5. Numbers like 81 because it comes from 9 times 9. Numbers like 3 and 18 and 20 are not perfect squares because there's no number that if we multiply it by itself gives us that value. Same thing if I do 3.6 because there's no number that if I multiply by itself gives me 3.6. Okay, let's talk now about irrational numbers and real numbers. So irrational numbers are any numbers that you cannot write as a fraction, a decimal, whether it's terminating or repeating. When we talk about irrational numbers, there's a few big categories that we talk about. Pi is always an irrational number. Any decimal number that just keeps going on and on forever and we don't see any sort of a pattern is irrational. And any square root of a number that is not going to give us a rational answer is going to be any number that's not a perfect square is an irrational number. Okay, so our real numbers are now this big category of all of our rational and irrational numbers. So we can make this little chart here and say, okay, let's think about all of our real numbers. They're divided into two groups, irrational and rational. And then our rational numbers, we have a smaller group inside of them that are our integers. And then there's a smaller group inside of our integers that are our whole numbers. And then there's even a smaller group that are the natural numbers. Okay, so let's classify some numbers. If I have 5 over 22, let's first think about, we know it's a real number. Is it rational or irrational? Well, it's already written like a fraction, so I know that it is rational. And then let's go down my categories and say, okay, is it an integer? Because that's the next smallest category. No, because it's a fraction, so it's not an integer. Well, if it's not an integer, it's not whole, and it's also not natural. Let's look now here at the square root of 81. So the first thing I want to say is, okay, it's a real number. Is it rational or irrational? Well, does the square root of 81 have a whole number answer? Yes, it's 9, which makes it rational. So then I have to say, okay, well, is 9 an integer? Yes, because it's positive, negative, and it doesn't have a decimal or fraction. Is 9 a whole number? Well, it's part of my counting numbers and 0, yes. And is it a natural number? Yes, it's a counting number. So it's also natural. All right, the square root of 56. Well, is there a number that if I multiply by itself gives me 56? No, and so it is irrational. And if it's irrational, it's not going to have any other categories that it belongs to. All right, let's talk about repeating decimals and how to turn them into a fraction. All right, the first thing we're going to do is we're going to find the part of the decimal that repeats, and we're going to put that in the numerator of my fraction. And then I'm going to count how many digits there are in the numerator, how many digits are repeating, and however many digits there are, if there's 2 or 3 or 4, I'm going to put that number of 9s in the denominator, and then I'm going to simplify. Let's look at an example. Okay, I have 0.27 repeating. So what's the part that repeats? 27. That goes in my numerator. Now I'm going to count the digits. There are 2 digits that repeat. So I'm going to put 2 9s in the denominator. So my fraction is 27 over 99. And now I simplify. They can both be divided by 9, and I have 3 over 11 is the same as 0.27 repeating. And the last thing we're going to talk about is how to estimate square roots. So what we're going to do is we have a number that is not a perfect square, but I want to estimate it. I'm going to find the 2 perfect squares that it comes between and pick which one is closer. So if I have the square root of 15, I'm going to say, well, when I think about my perfect square numbers, this is a little bit smaller than the square root of 16, which means that, and since that's 4, the next perfect square that's smaller is going to be the square root of 9. So because it's between the square root of 9 and the square root of 16, it comes between 3 and 4. But the one that it's a little bit closer to is the square root of 16. So the square root of 15 is about 4, a little bit less than 4.